Thanks, Jess, and also thanks to Mark Avery and Grain Journal for the opportunity to speak to the group this year. I've been to the CONVEY conference, I think, 2 or 3 times, generally speaking about grain quality, food safety, safety, the intersection of grain quality and safety. And so we're going to talk a little bit more about grain quality and safety this afternoon. I'd like to start with just a few facts on grain entrapment as we talk about that intersection of grain quality and safety in your facility. These facts were current as of earlier this spring, April timeframe, so maybe they've shifted a little bit or more data. So just a couple facts here. Suffocating from entrapment is the leading cause of death in grain bins. We know that entrapment is a big issue in our business, and some of the quality factors that we're going to talk about here this afternoon can lead directly to that entrapment and then engulfment. Primary cause leading to entrapment was entering a bin to loosen crusted, spoiled, or frozen grain while unloading equipment was running. And so we'll talk about why some of these factors happen in our bins, the quality aspect behind it. Over half of the engulfment incidents report resulted in fatalities. So I think as an industry, there's been a lot of focus on engulfment and safe entry into bins because we know, and some of us know personally, the end result, and it's not good. Interestingly enough, at least to me, I grew up on a grain farm. 69% of entrapments occurred on the farm, while 31% occurred at commercial facilities, so in our industry. And I can tell you from firsthand experience, I never thought about it growing up on the farm. I've climbed in grain bins all my life and never thought about the hazard and the risk associated with a potential engulfment and the impact that quality has on that risk. So some of those issues that are caused by poor grain quality, bridging, cliffing, rat holing, reclaim blockage, structural and wall issues, and we're going to talk through each one of these. Before we get into some of those details, I wanted to start with some grain quality tenants that some of you in the room probably know Charlie Herberg. Occasionally he has these published in Grain Journal, and I really think there's some good words to live by when we're talking about grain quality management in our facility. So the one thing that we need to start with is grain quality never gets better, right? So the day that grain hits our facility, whether it's a small country elevator in Illinois, a river house in Missouri, or the export elevator in New Orleans, that's the best quality that grain is going to be at any time, right? So grain has one mission in life, and that's to spoil, so it never gets better. We can only hope to maintain it while we're storing that grain in our facility. And then once we've had grain that has gone out of condition, it will always be a storage risk, right? So as soon as you start to have a problem with any kind of damage, moisture issues, you're always going to have a risk in trying to manage that grain. And it's also more costly to handle and store when we have poor quality grain. I think probably all of us are familiar with, we buy a load of corn from a producer that's high level of damage, and we know that it's going to be more costly to handle, right? We're going to have to pay more attention to it. We may have to dry it. We may have to bin it separately. It's always more costly to handle grain that's got poor quality. One of the things that I'll talk about as we go through some of these quality issues are some of the tools that we have to help us manage grain quality. But what we have to remember is that there is no silver bullet for monitoring and managing grain that's in storage. So we'll talk about a few different tools, and what we have to keep in mind is you have to put all of that information together to come up with the true picture of what your storage risk is. If you do not grade or inspect all of your inbound grain, you don't know what you have in storage. It seems like a basic principle, but think about your facility in October in slot corn harvest. What happens? We may not even grade the trucks coming in. And what happens if those trucks, it's harvest, we always assume it's good quality, but what if it's not? What if we've got an aflatoxin problem? Or what if we have an FM problem in soybeans? Anybody concerned about FM in soybeans these days? Anybody shipped to China not shipped to China these days, right? So grading your inbound grain, it's really important. And sometimes we forget about that because we're more concerned about getting that grain in the house and through the house as fast as possible. I agree wholeheartedly with Charlie on this one that moisture is the most important factor that you can measure. Right? You need to know what the moisture is because that tells you the risk of storing that grain. Right? I think it's a no-brainer for most of us, but the higher the moisture content, the higher the risk of storing that grain. And we'll see some charts here in a couple minutes that back that up. But you've got to know what the moisture is that you're putting into the house, whether you need to dry it, you can simply aerate it, blend it out, or just manage it as is. If you are drying grain, but you're not drying it properly or uniformly, aeration won't always correct that. And so you need to understand if you are running a grain dryer, am I running it properly, right temperatures, right speeds, is the grain being dried uniformly, what's the condition of that grain as it comes out, so when it goes into storage, you know how to manage it. And then lastly, many aeration problems that we have can be eliminated by coring the bin. And so if folks don't understand what we talk about when we core bin, when you fill the bin, you get a spout line of fines more in the middle, and air does not flow through that spout line as well. And so you have difficulty aerating that grain. It can take multiple times more to get air through that spout line to cool the grain down. So we used to have an employee at Cargill several years ago, before my time with the company, bad haircut Herb. And as I mentioned, his saying used to be, grain has one lot in life, and it's to spoil. And he was right. He may not have known exactly why he was right, but he was right. And really what it comes down to is you start to have damage in your grain, and that could be because it's hot, could be wet, you could have insects in the bin. But what happens is that grain becomes damaged or moldy. That creates water, heat, and CO2, which we'll talk more about CO2 in a little bit. And then what does that water and heat do? It creates more damage. And what does the damage do? It creates more water and heat. So once you start to have that quality problem in your bin, it's a self-replicating problem, right, until you do something to stop it. And that could be dry it, it could be aerate it, and we'll talk about some of those tools and actions. So bridging grain. I think most all of us in the room understand the concept of bridging grain. We get that crust that forms along the top of the grain, and we end up with that bridge, and when we start to pull it, you start to get the void in the bottom. Poor quality, heat, frozen grain. This was an aspect I hadn't really thought about too much, but frozen grain can cause bridging as well. One of the questions I commonly get in my role, at least at Cargill, and I've heard it discussed at a lot of different conferences, is when I'm aerating grain in the winter, how cold do I get it? And I've heard that answer, the entire range of answers, right? I've heard people swear by, get that grain frozen, get it as cold as humanly possible, store it that way, hold it. And I never thought about this aspect of what if you've got some mid or high moisture corn in that bin and you freeze it and now you've got this crust potentially on top, right? And you've got that risk for a bridge and you may not realize it or notice it. And so it can present a safety risk. Personally, I'm not in favor of getting grain down below freezing. It's a waste of time and it's a waste of energy because the molds and insects stop at about 35 to 40 degrees. And again, I think we all know that if the person walks across that bridge, there's a risk of it breaking, and now you're going to be down in the grain. So we know it can be a serious problem. And how serious it is going to depend on the thickness of the crust, the size of the bin. And so if we think we've got that situation right, we need to have a well-developed plan on how to manage it. And certainly, we don't want to be putting people in the bin, but we need to understand that risk if we're in a situation where someone has to be in the bin, and what's our plan to deal with it. And I put this slide in here to show another example of how you could get bridging in grain. This slide's originally intended to talk about when you aerate the grain and whether you use up air or down air and the transition layer between cool and warm grain. But what you can see here is, so what if you do this? You've got good cold grain in the bottom. You put warm grain on top of it. You're running an up air system. It's a great system for doing this, right? Because you can continue pushing that cool front up through the grain and get your whole bin cooled down. But what if you don't get that front all the way through the bin and it stops right here? Now you've got that zone where you have an increased risk of spoilage in the grain, and now when you start to pull that grain, what if you start to get a bridge, a void in here, or a rat hole. Now you've got a quality problem and a safety problem. And so it speaks to the importance of understanding when you're aerating your grain, what are the conditions? What are the moisture contents? How long are you going to aerate the grain for? And then how can you ensure that you'll get that cooling front pushed or pulled all the way through the grain, so you don't have this layer where you've got the increased risk of spoilage. And again, here you can just see another visual example of this. In this case, it's with down air, and now you've got this opportunity for spoilage on two fronts. And you're not also presenting yourself with a bridging risk, but when this layer starts to break up, when you do pull the bin, now you've got that risk of clogging the spouts, right, and having to deal with a clogged spout, and whether that's having to, we heard somebody mention this morning, having to rod out spouts, if you have to put someone in the bin to break those chunks up, and again, now you're putting someone in harm's way, even when you're rodding the bin out from the bottom, right, you still have that risk of somebody getting hurt. And just another example, but a little bit in the opposite direction, right? If you have warm grain on the bottom, cool grain on top, it doesn't really matter, but what matters is this risk of spoilage right here in the middle, where you've got that transition between the cool and warm grain. And it's going to present safety risks, it's going to present quality risks, and now you've got something to manage, whether it's blending it out or grain that has to go to the landfill. Cliffing grain, very similar, I would say, to bridging grain, but now you're getting it built up along the sides of the bin, right? So it could be just in one area of the bin, could be along the wall. Likewise, and we'll see some pictures of, it could be in the middle. You could have a pillar staying up in the middle. Same basic causes, right, as all the quality factors that we're going to talk about today. Infestation, hot spots, high FM concentrations, high moistures, all could cause a cliff. And now we've got that risk of, if we put a worker in there and they're poking at it with a rod or a pickaxe or a shovel, that it can break loose and fall on top of them. So you can see some great pictorial examples of it. And if we have to, ideally we can work on this from outside the bin, whether it's with a third-party company that can clean bins out, or you can work from the outside of the bin with whatever tools you need. But if we do have to have someone in the bin or structure, if it's a large flat or a ground pile, making sure that we're working from a distance away, where if that cliff does fall down, we're not putting someone in danger of it falling down on top of them. And again, just another example of some cliffing. This is a little more interesting example, and this one was at a Cargill facility where we had a flood out of season. We weren't expecting the facility to have water, and they had one of our largest tanks in the company get you can see about 4 foot of water in it. They had a problem, right? That's pretty obvious. But the more important point is, what did they do once they had the problem, right? And there was a lot of communication, a lot of emails, a lot of phone calls that went around to say, okay, we know we've got this problem. Not only do we have to deal with putting the facility back together, cleaning up the rest of the facility, we've got this tank, and FDA comes calling because they know we had flooded grain, right? So now we've got our own internal stuff to manage, and we've got an FDA compliance officer breathing down our back saying, hey, that's flood damaged grain, right? So a lot of communication and a lot of effort went into the safe planning, right? How can we make sure that when we get those Bobcat doors open, we're not going to put somebody in harm's way or risk, both from an atmospheric situation, right? Make sure that we've got good oxygen levels, we don't have any carbon dioxide or CO buildup. People can get there safely. They can work to break this crust. They can get it out of the bin and manage it safely. The end result was that we got the bin cleaned out. But what I want to leave the group with is, the amount of planning that goes into managing it once you have a situation. This was a situation where it wasn't necessarily caused by our poor quality management. God knows we have enough of that anyhow. But it was a case where we just weren't prepared for high water. And so making sure that you've got a plan to manage the stocks in your facility. And I'll talk maybe a little bit more about that here yet this afternoon. I mentioned the reclaim blockage when we looked at some of the other pictures around bridging, and really it can happen when you have any sort of quality condition, quality concern or situation in your bin, right? The reason the reclaim becomes blocked, and it's usually because we've got some large clump of grain that falls off, breaks off a bridge, whatever the case may be. Could happen for a number of reasons, right? Could be roof leaks. What if we left a hatch cover open? Or what if we had a hatch cover blow open on us? Certainly that's happened before in the industry. We have that crust or that bridge that breaks up. High moistures, and we'll see an example here in the next slide that shows just some natural occurrence of high moisture that could cause this. And as we've talked about just in general around engulfment, right, that worker can get pulled into that flowing grain and be buried, and we know that that's not a good situation. We never want to put a worker in that situation where they're inside the bin trying to break up chunks or anything that's blocking that discharge spout. It doesn't end well. So one of the things that I wanted to talk about, and I hadn't really thought about it in these terms until really when I was working on this presentation. So what can happen in your bin, and this doesn't have to be when you're holding mid or high moisture corn, although I would say it's more likely to happen, beans, any commodity for that matter. But what happens is as you've got that storage bin and you're transitioning between seasons, and it's essentially the same between winter and summer to winter, you get natural air currents through that bin, right? So this is winter into summer where you've got good cold grain maybe in that bin. You've got the warm sun beating on that bin, and you'll start to get some natural convection currents, some natural airflow in this bin. And what happens, or what can happen, is you've got that warm air moving up, hits the cooler grain more towards the center, and you can start to get moisture accumulation in that part of the bin. You can get spoilage in there, and you may not always see it on the surface of the grain, right? You may look in that manhole or that hatch cover on top, and the grain surface looks fine. This could just be right under the surface. Well, now you've got that risk, like we talked about, right? You could have bridging caused by this, or what happens when you go to pull this bin and that clump of moisture, that high damaged grain starts to break up, right? Now again, you've got that situation where you have clumps that might be clogging your spout, and you've got to deal with those. And again, this may not be caused by any sort of poor inventory management in the facility, right? It could be the natural air movements in that bin, but being aware and understanding that can happen, and maybe that's a signal potentially to the location, hey, you know what, when I'm in these transition periods, and if I think I'm going to be shipping grain maybe in the next few weeks, I want to start warming that bin up a little bit so I can maybe reduce some of this risk of getting the spoilage at the top of the bin. Rat holing, again, I think I've alluded, a lot of these are very similar in nature, right? So when we get that tunnel forming in the grain mass while reclaiming the grain, so it could be related to cliffing potentially, depending on how bad the situation is in the bin. High FM concentrations, high moistures, out of condition grain. I think you're going to get sick of hearing me say high moisture, grain out of condition, right? It's the story of our life dealing with that. The same problems, right? These rat holes can lead to voids, bridging, cliffing. They're all similar, and the risk is that breaks down. And not only is it a risk to safety to a person, but it's a structural safety risk as well, right? So if that cliff or that bridge or all the built-up grain on the sides of the rat hole decides to fall all at once, you've got that structural risk of causing the bin to collapse. It could tilt the bin one way or the other, cause it to collapse. It could blow the bottom completely out of the bin. We had that situation happen actually in a Cargill facility in South America. Everybody thought they were doing the right thing by managing the bin. They knew they had some hung up grain in the bin. They had a safety plan in place, but when that cliff broke loose, it knocked the whole cone out of the bottom of that bin. And not only did we have a big mess, but some pretty serious injuries related to it. It's the same story around the best practices, right? Don't put anybody in the bin where they can get engulfed or trapped if any of that grain collapses. This is a great example, particularly if you've got a rat hole bin where bin whips can be used. and knock those out and start to clear that bin out. So again, you can see, if you look at this picture, looks very similar to cliffing, but you can see right down here that hole starting to form, right? And the questions I'd be asking the location, what's your plan? How are you going to start knocking this down? I don't have a lot of details on the angle where this picture was taken from. Is this through a bobcat door? Can they pull the bin safely, put a front end loader in there, put a bobcat in there? But that should all be part of the plan, right? How are we going to manage this now and keep our team out of harm's way, but still get this grain out of the bin? I had mentioned spout lines a little bit ago, and I got to thinking more about spout lines and rat holes and the quality risk and the safety risk presented by that. And so I don't think, or I'm probably surprising anybody with this picture, right? We get the fines built up in here. But understanding that happens, right, and the risk in our bin associated with it, and are we trying to pull those, do we have the time and space and the ability to pull those spout lines out to make sure that we don't get those set up to cause a bridging or a cliffing situation? Or what if we think we're pulling that spout line, but it's only the spout line coming out and we're leaving a rat hole in the bin, right? And so understanding how the grain flows in the bin, the risk associated with it, and what's our plan to manage it. And just a similar example, this is more talking about the airflow through the bin and how that spout line can affect it. And what you can see here is this represents a down air type system where they're pulling the air out through the bottom, didn't pull the spout line, and you get this spot of grain in the middle that won't cool down, right? Or it could take several times longer to cool down depending on the amount of fines that are in the bin. And so, again, does the team at the facility understand that this could be happening? Do we have a plan to manage it? Do we know the quality risks that it presents, right? Because if this spot starts to heat up, now we've got more damage. And again, we talked about that damage is a self-replicating cycle, right? So do we have a plan? Do we understand it? Do we have a plan to manage it? And a lot of these quality issues can lead to the structural issues, right? So I used the example of when that rat hole falls, but just having the damage in the bin, right? That out of condition grain, it sticks to the walls, traps moisture against it. How many folks have ever had their bin walls sweat, right? Particularly as you transition between seasons, right? And so what can happen, right? You start to get this nasty, rusted, it's hard on the sheet metal, on the pieces of steel, the core, whatever the case may be. Now you've got structural issues to deal with, right? And again, that same thing as we're managing that quality problem, trying to get that grain out of there, do we have risk of something happening with the structure? So make sure when you get bins empty, right, we're inspecting those structures, we're getting in there, we're checking to make sure that they're not corroded, we don't have grain hung up on the wall. Because also, by the way, that grain hung up on the wall also becomes great harborage for insects, right? And so a lot of good reasons to get in those empty bins, check, make sure they're clean. If they're not clean, make sure they're getting cleaned out. If you start to see corrosion, make sure we're putting a plan in place to fix it, right? Manage it, make sure that we're keeping our facilities and our people safe. And I could stand up here all day and show pictures, unfortunately. So, just another example of grain that was crusted over. I don't think we're surprising anybody. But what I like to talk about when I share this with our training folks within Cargill is think about how you're going to manage this when you find this situation in your facility. I think those of us that have been around the industry for a while, despite our best intentions, if you haven't dealt with something similar to this, you're probably not working in a grain elevator, right? We've all seen this in our facilities. And how are you going to manage it? Do you have a plan to get it out of the bin safely? Can you blend this off? Where can you blend it to? What levels can you blend out? Are there certain customers that are willing to take more damage, less damage? And then are we keeping that safety in mind, right? I'm pretty sure this is going to end up in chunks at the bottom of the bin. And how are you going to manage that if it happens? And so, again, similar picture, but now we've got that crust broken up. And what always gets me when I talk about this picture with folks is, now not only do I have the quality problem to deal with, but I had probably what was a whole bunch of US #2 corn, right? A whole bunch of really good corn that maybe was slated to go to a particular customer, and now I got to manage that issue of the damage. How am I going to do that? So what I want to spend most of the rest of the time talking about is what are the keys? And when we talk about keys, really in my mind, that's talking about what are the tools that we have at our disposal to use to help manage that grain quality while we're holding it in storage. And so maybe some of you are familiar with the fire triangle or the pest triangle, and you take one of those legs away and it reduces your fire risk or your pest risk. And I like to think about it as a grain quality triangle as well, right? You've got the risk of molds and insects, moisture and temperature, and if you can take any one of those three away or reduce any one of those three, you reduce that risk of having quality issues in your facility. And we'll talk a little bit more about some of how these interact when we talk about grain quality and grain storage. What I want to talk about first, though, is Monitor, Inform, Act, MIA. I like to think of these as key components of managing grain quality, and if any of you have heard me speak previously, I talk about this all the time. Almost every presentation I do about grain quality talk about Monitor, Inform, Act. It seems like such a basic concept in our industry, but the biggest problems we have are because one of these steps gets missed or not properly executed. And so when we talk about the monitor piece, what are the tools? We've got a lot of tools in our industry to help us manage grain quality. And I've taken the opportunity to walk through the trade show at least up and down every aisle, and there's a lot of folks in there that have a lot of great tools at our disposal, right? And we have a lot of considerations on which ones to use and how to use them. And like I mentioned, we take all that information from the various tools and we start to put it together to get that picture of what's the quality in my bin or in my ground pile or in my tank, what's my quality risk, what's my storage risk, and how am I going to manage it. So we mentioned just a few slides back, proper cleaning, right? Once you get those bins empty, whether it's each season or you turn your bin multiple times a season, are you getting in there and making sure that they're cleaned? Right? Because when we have that grain hung up on walls, when we have a crust on the floor or in the corners, that's insect harborage, and if it's damaged grain, now you've already left the seed in there to create more damage the next time you put grain in there. And then, another great reason for getting your bins clean, as you're switching commodities, one of the things that we're seeing more and more is customer demands or customer requirements around making sure we don't have wheat in our corn or beans in our wheat. And we see more food safety requirements around managing the commingling and allergens. And so not only is proper cleaning a physical safety, but it's becoming more and more of a food safety piece as well. Temp cables. I think every one of us is familiar with temp cables, and we've all have or been at facilities where we have temp cables. It's the basic tool that we have in our facilities. Deep probing. I'll talk a little bit more about this one too. So I'm not going to give that punchline away. Deep probing is another tool. CO2 monitoring, we'll talk a little bit more about this. Another one that I think oftentimes gets overlooked a little bit is using your 5 senses, right? Getting out into the plant, walking bins, walking flats, sheds, ground piles, smelling the grain, picking the grain up, checking your fans, making sure that there's a good smell coming, a good, cool, sweet smell, and we're not getting sour or musty. I think it's real important to be in the plant regularly, just walking around. Having a good grain storage and monitoring plan, and we'll look at a couple examples of these. And then we've been talking a fair bit about the safety piece, right? Making sure that we've got a plan in place to keep our folks safe, whether that's after we've identified an issue or when we're doing some of these activities to monitor and manage grain quality. Right, I mentioned, walking piles or walking bins. Are we doing that safely under conditions that are safe? And another old timer in Cargill liked to use this quote: "Proper planning prevents poor performance." Right, having a good plan, make sure that we're going to be able to manage our facility, our grain quality, and our safety a lot better. So who do you inform? This is going to be as different as every facility we have represented in this room, right? Personnel, your organizational structure. And so to me, it's about, have you had a discussion with your team? What are your expectations? What should they be communicating? Who should they be telling? And how often should they be telling you, right? And again, it'll be different for almost everyone in the room, but have you had that discussion, whether it's with a superintendent or plant manager or the production employee? You know, I heard a great comment, I think it was from Melissa in the previous panel, about, you know, do the folks understand the importance of it? It's real easy to tell someone at the facility, hey, you need to monitor the temperature in that grain bin every week, Monday morning at 7 a.m., and you'll probably find somebody that'll do it like clockwork. But do they understand the importance of that tool of checking the temps every Monday? And then what do they do with that information? Who do they tell? How do they react? And I use this quote a lot. Again, if folks have seen me speak previously, I use this almost every time I talk about grain quality. You might ask, why would we use a quote from somebody with Avon, right, the mail order cosmetics? It's a great quote. Come to me early with a problem, and you're going to have a partner in finding a solution. Come to me late with a disaster, and you're going to have a judge. And it really speaks to that informed piece, right? The folks I know that have been least successful, for sure in Cargill, and I'd venture to say in industry, are those folks that thought they could hide the problem and get away with it. And in my experience, it's ended poorly, right? It's ended with the put your keys on the desk and walk away moment, right? And it doesn't go well. And you know, I put this picture up here because it's an example of where it maybe didn't quite work as well. You know, team thought they were monitoring and managing their grain quality. It turns out they had a pretty significant hot spot, and by the time it got communicated, you know, this is what it looked like. It didn't feel good, and I can tell you that that facility got a visit from a judge and jury, not somebody there that was trying to partner and figure out how to manage the situation, right? And maybe had we started that conversation a month or 6 weeks earlier, it would have been a different scenario. So, you know, I encourage you to have those discussions with your team. Come to me early and often, and let's work through it. We'll manage the issue. The folks that hide it, that think they can blend it out, it's probably not going to go so well. So the A piece, how do you act? I make the argument, just by telling somebody you've taken action, you've done something, right? But we've got a lot of actions at our disposal in our grain facilities, right? We can turn the grain. We can fumigate the grain. We can load it out. We can ozonate it. We can dry it. We can aerate it. We have a lot of tools to manage quality issues once we find them. The key is knowing that we've got the tools and figuring out the plan on how to use them. It may be the complete right idea to take that 100% damaged grain and blend it off to somebody. We may have a customer that we can manage that with, right? But we've got to understand that and have those discussions. What do you need to do when you find that quality problem? What actions do we want to take? But again, the number one thing, don't hide it. It's not going to be a good day, right? It's going to feel bad. It's going to end poorly. And a great quote from my friend Bob Marlowe, who's spoken at several conferences like this. Quality problems have a compounding effect, all right? So I think we've seen that already in the slide with how mold, the grain becomes moldy or damaged, it produces heat, water, CO2. It's self-replicating, right? The problem just keeps going, and it makes itself worse and worse. And if you want to see a good example of that, this was a barge of soybeans. And we know this. It was loaded at a location upriver. The facility that loaded it didn't tell anybody that they put high moisture soybeans in their blend. But the average grade on that barge was 13.5 or 14.0 soybeans. Floats down the river, and this is what we end up with, right? So the problem made itself worse the whole time it was sitting on the river. Now we've got a barge sitting down in the Gulf that's basically on fire, and we've got to deal with it and talk about the safety hazard, right? Now you've got somebody found out that this barge looked like this, and I'm sure that was a real fun job. But now we've got to manage it. You're putting somebody in harm's way to get the covers off and start to move that grain out of that barge. And what do you do with it on the river in New Orleans? And throw it in the river is not the legal answer. But you're putting somebody in harm's way to deal with it, right? And had we just had some communication with the upriver team to say, you know what, I got to put some high moisture beans on a barge, or hey, I've got some quality concerns about this barge, maybe we could have avoided it at the other end, right? So are we having that dialogue internally with our teams to say, you know what, I recognize that, upriver facility X, you're having some wet beans come in. Let's put all those on one barge. We'll hot shot it to the Gulf. We'll discharge it. We'll run it through the dryers down here. We've got better capacity. You need to stay fluid, right? Are you having that discussion with folks, making sure that everybody along that supply chain knows what's coming down the river and that they can manage it and manage it safely? So when it comes to a grain storage monitoring plan, I like to look at them kind of in four ways. You can take the head in the sand approach, cover your head up, and just hope that, after I've stored this corn in my facility for 18 months, that it's going to come out good. Somebody can beat me into doing it, right? Comply or suffer. I can brute force it and hope it ends up well. But instead, what if I had a well-measured plan where I went through MIA and talked about what tools am I going to use, how often am I going to use them, who's going to do it, who am I going to communicate it to, and then when I see those issues, how am I going to act? What am I going to do with that grain? And so having a good storage monitoring plan, the first thing you have to recognize is everyone is going to be different, right? We all have something different about every one of our facilities, and so the plan is going to be different. It's going to be based on every facility, how long you hold grain, where the grain comes from, moisture contents you handle, et cetera, et cetera. So recognize that it will be very site-specific. The more detail that you can put into it, the better it's going to be. It is a plan to say, I'm gonna retire at 65. It's a much better plan to say, I'm going to put 15% of my 401k, I'm going to max out my IRA, I'm going to monitor my expenses every month, right? A more detailed plan, it'll go better. The same thing relates with grain storage. You also have to take into account changes in your plans, right? What's your contingency? We've heard it referenced a couple times this morning, the great relationship we have with the railroads. There's no railroad folks in here, is there? The plans change, right? We expect that train to come in. We expect the barges to show up. We know, right? There's problems on the river. There's delays on the railroads. And so what happens if we can't get that freight? What happens if every facility in my region thinks they're going to pick up their 18% moisture corn ground pile in the same week, right? Can we get freight to manage that? So it's going to change. Or what if the market goes from an inverse to a carry, or vice versa? So make sure that we've talked some about those contingencies on what are we going to do when conditions change. I've already talked a lot about the communication piece, and right, a lot of times, in my opinion, we tend to get siloed, no pun intended, within our operations group. Well, I told my plant manager, or I told my regional operations leader, or my business operations leader. But the commercial teams, the trading teams, the accounting teams, they may need to know as well. And so have you taken communication with those groups into account as well, right? We need to make sure that the inventory is correctly valued. And the commercial team needs to know if they're making trades, hey, if you think you're going to sell U.S. number 2 corn out of tank 3, it's not even sample grade corn, right? They need to understand that. So make sure that communication is built into your plan. Security considerations. We don't want to forget about security. That's a different kind of safety in the facility, right? Making sure that whether it's cameras or gates or fences or whatever the case may be, we've thought about the security of that structure. And also think about what if it's a structure or storage that's not located on property? What if you've got a bin out in the middle of a farmer's field, or you've got a remote ground pile? How are you going to manage security at that facility? And then one thing that we do within Cargill is we have a defined program on inventory management. And so make sure that that storage monitoring plan is part of your overall inventory management program. And so just a couple examples that I've put together. You can argue whether these are good, bad, otherwise, but just maybe something to start thinking about what's the plan for storage monitoring in my facility. So we've got a concrete upright space, take temperature readings weekly, have a temperature system that automatically flags rises in temperature greater than 20 degrees, and then what's the action that's going to be taken, right? If we start to see the temperatures rising, we're going to run the aeration to cool the grain and manage it. And then if we need to, we're going to turn the grain. If you want my opinion, this is probably a mediocre plan, but for the facility, it may be just what they need, right? And so again, think about the facility, the activities that are going on, but have a plan. A remote flat, right? So check the security each week. Doors, gates, vents, make sure they're secured to prevent that uncontrolled access. CO2 readings every 2 weeks. When it's filled, we're going to collect samples for every 250,000 bushels. We're going to grade those, and we're going to send them in for baseline mold testing. We'll talk a little bit more about mold testing here in a minute. And then we're going to probe that flat again every 30 to 45 days when it's safe to do so. We're going to send those samples for mold tests, and we're going to grade them. And then if there's any quality concerns, we're going to collect samples more often. I think, and I don't want to overlook this when safe to do so, right? So a lot of folks represented here probably have ground piles. If that cover on that ground pile is icy, snowy, slippery, we don't want to put anybody in harm's way to be up there collecting samples. There'll be another day to get samples. But we want to make sure we're taking that into account. Likewise, if we're getting into bins, flats, whatever the case may be, make sure that it's safe to do so, and particularly as we talk about confined space entry in our business, that all your confined space entry rules are being followed. So again, just some pictures of quality problems in a storage structure. This is severely heat damaged grain. And again, you've seen a little bit of this picture previously. So proper bin prep and clean. I've kind of talked about this already, right? Making sure that we're inspecting it, we're getting it repaired, cleaned before we fill it to reduce those chances of grain storage, grain quality issues. Leaks in roof, right? And I don't care whether it's a bolted bin or concrete. I bet I could get almost everybody in here to raise your hands about you've had a leaky bin roof before, right? And what happens? That grain goes, that water goes in the grain, and now you've got a hot spot in the making, right? So making sure that we're fixing those when we find them, understanding that we're always going to have to take that cost piece into consideration. Inspection of air ducts. I mean, that's vital to proper aeration and reducing those hot spots, right? Because what happens if you start to get a crust that builds up on that aeration? You don't have aeration anymore, right? The air won't go through it. And so making sure that your air ducts are in good repair, they're not crushed, they're not covered with grain or dust. I'm pretty sure they didn't do a good job of monitoring and managing quality in their facility, right? And now we've got to try and figure out how to get it out and get that bin clean, because if we're putting grain back in on top of a situation like this, we're just asking for problems, right? We're setting ourselves up to have a quality risk. Or if you have to put somebody in that bin, you've got a pretty significant safety risk, right? And so making sure that we're managing the quality and using those tools that we have, and we're going to talk about a few more tools yet. So temp systems, like I mentioned, I think this is essentially ubiquitous in the grain business, right? We have temp cables, been used several years, all kinds of systems out there, right? I know there's at least one, if not multiple vendors out there. on the trade floor that have different kits. You can get an entire range of examples, right? And I think sometimes, at least in my experience, our facilities forget about that I don't need the Cadillac to manage, to be able to monitor temperatures in my grain bins. You can still do it with a pretty simple system. The key is having that system and using that system. It doesn't do us any good to have the system and either A, not use it, or B, how many folks have facilities that I've got temp cables, but 89 out of the 100 thermocouples are out? Yeah, right? So, and it happens, right? I mean, I've been around our industry. I've been to enough of our facilities. I know it happens. What good is it to have the system if it's not working and you're not using it, right? And now there's some really cool stuff coming out of some of these suppliers on, they can monitor moisture levels or actual monitor bin levels based on where they're getting temperature readings. I mean, there's some really cool technology to have some really good tools to help you manage your inventory and manage quality when you're storing grain, especially for long periods of time. And, the caption talks about being able to identify these hot spots because of the indicators on the temp system. And I think one thing that we sometimes overlook is, the proper installation of those temp systems. Now, I'd like to believe that, technology has moved forward, relationships with vendors have gotten better, and so maybe this isn't as big of an issue today as it was 15, 20, 30 years ago. But something that I talk a lot about with folks is grain is a really good insulator, right? And so making sure that you lay that cable pattern out properly ensures that you've got good coverage. And I think this is a great example here, right? A cable will get you about, and I'm sure somebody from one of the suppliers is going to correct me, you can get about 8 to 12 feet radius from that temp cable and still be reasonably effective, give or take. Right, so you can just see, if you've got that 42-foot bin and you only put one cable in it, I mean, you're wasting your time and your money, right? I mean, what are the chances that that hot spot's going to be right there where that cable reaches? So making sure we keep that in mind when we design and install the cable systems and make sure that you get that good coverage of that bin, right? If someone were to ask me, I'd probably want to add 4 more cables to a bin like that. But recognize that grain can be a really good insulator, and we may not catch that hot spot until we've got that cliff or that bridge forming because it was too far away from the cable. I mentioned the deep probing. This is a great tool if you've got a porta probe or a vacuum probe on ground piles and big sheds or flats where you can get in there and you can collect samples. The key is to using the deep probing is make sure you lay out a good pattern, right, where you're getting good coverage of the grain that's representative of the grain in that storage structure. You want to get that probe in as far as you can. Has anybody in here used a porta probe or a vacuum probe? If you're lucky, 16, maybe 20 feet in, but anything is better than nothing. I like to recommend start out with doing that, getting that sample or those samples every 30 days. Again, safe to do so, and it's got to be in compliance with any confined space entry. And then don't forget, grade those samples. This is sometimes overlooked. We pull the sample, we smell the sample, we send it in for mold testing to make sure that we understand what the mold load is in there, right? We talk about that triangle, but then grade it as well, because just understanding the damage and the moisture can tell you a whole lot of good information about the quality and the storage risk. CO2 levels. CO2 is a great indicator of potential spoilage. There's been a lot of research done at Purdue, K-State, I think Iowa State has dabbled in it. There's a lot of information out there around CO2 monitoring. It's a great tool where you can get those air samples either from the bin headspace or from the exhaust on the fan. And as you see CO2 levels change over time, it gives you an indication of quality in the bin. One of the questions I get asked often is, well, what's the danger level? I'm taking my CO2 readings. When do I get concerned? You get the readings in parts per million if you're not familiar. There is no set level. There's some real good research out there from Purdue University where they had levels all over the place and there wasn't a great correlation. So what I tell folks is you need to watch that trend over time. If you're seeing that CO2 level continually go up week after week, you probably have a problem in that storage structure. Or if you see a great big jump from one reading to the next. So it's not a hard and fast, at this level you've got a problem. You need to watch and see what's happening over time. Talked about your 5 senses. Never underestimate that visual inspection, right? Getting in there, looking at that grain, color changes on the surface, condensation, whether it's on the walls or on the roof. We talked a little bit about leakage, the smell, right? Smelling fans, smelling bin tops. One of the first lessons I got in grain quality was walking a bin deck in Topeka, and we walked along. I was walking with another supervisor, and he dead stopped, and he did one of these, scrunched his nose up, and walked back about 3 steps and opened up the bin hatch, and the smell was knocked us over, and the hatch was sweating. They had a heating problem in the bin, right? And it was all just his knowledge and understanding of, I'm just paying attention to what I smell when I walk through the facility. I mentioned this piece a little bit already about cooling the grain. Getting it below 35 to 40 degrees, it doesn't add any value in my opinion. The insect activity has stopped, the mold growth has stopped, and we'll see a couple charts here. I'm also a big fan of get it cold, keep it cold. If I'm going to be storing that grain through the summer, that corn in that large tank in northern Illinois through the summer, I'm going to get it cold and I'm going to keep it cold. I'm not a big fan of warming that grain back up unless you're going to be shipping that grain, right? What you don't want to do is take really cold grain out in northern Illinois in July and put it in a barge and send it down the river, because it's going to end up looking like that barge picture I showed you before. So you have to understand your market. But if you're going to store grain and hold grain, I don't think you can go wrong if you get it cold and you keep it cold. Just some examples of the temperatures that those molds like, so the storage molds, right? So when you start getting down in this 45, 40 degree range, the mold activity stops, so you're wasting time and energy by trying to get it any colder than that. Conversely, this time of year in Omaha, and we're right there, right? So understanding that risk. So if you've done your mold test and you have high levels of mold in the grain, and you've got slightly higher moisture grain, and you've got these temperatures, you've got a risk for storage molds, right? And you can see that correlation with the temperatures. These are the storage molds of concern, generally recognized as storage molds of concern, and you can see these varying moisture contents that they thrive at. So when you start getting, this is for corn and wheat, you start getting down into these lower levels, which is not ideal from a commercial perspective, but it's great for a grain storage perspective. So being able to manage that, 14.5, 15.0 market with the potential risks. And so these are some charts. They've been various universities have developed these. The only thing I want to say about these is they're a great tool to start with. They aren't the end-all, be-all. So what they're saying is, based on your moisture content of the grain, this one's for corn, and the temperature, this is the estimated amount of days that you can store that grain. That doesn't mean, we've got this one here at 16.0 and 45 degrees. It doesn't mean that at day 386, the corn in that bin turned to crap. But it's more focused on the amount of time to decrease quality by 1 grade factor. And I tell folks, internally, you got to use these a little bit with a grain of salt. It's to help you start to get some understanding of what's the risk, of putting that grain in the bin in October, or I get stuff off the farm in June. And so it's be thinking about, what's my storage risk if I'm going to put low moisture, mid moisture, high moisture corn away. Maybe it's going to be ahead of the dryer in the fall. What's my risk of starting to have quality problems? And a very similar chart for soybeans. And again, this isn't to say that you can't store corn and beans and wheat and milo for years, right? I mean, I've seen wheat have 9 birthdays in storage before. Doesn't mean you can't do it, but understanding the safe conditions to do it. I've mentioned, the aeration fans and cooling grain, and I'm a big fan of, once you get that grain cool, you put a cap on the fan. It stops that air from still going in the fan, and it minimizes this risk of crusting, right? We've talked about the safety risks and the quality hazards, and so making sure that, big fan of capping the fans once you get the bin cool, but then don't forget that you had it capped when you go to start the fan again at some point later. And if you've got vents on the top and you've sealed those vents, don't forget that you put seals over the vents, right? You either blow them out or suck them in. And just a picture of what that could look like. But think about trying to deal with this now if you've got that crust over your aeration ducting. So just a couple things I'd like to leave everybody with is, at the end of the day, we want to do everything we can to maintain the quality of the grain as it moves through our grain facility and ensure that everyone who comes to our facility each day goes back home safely, right? We know grain has one mission in life, and it's to spoil. We want to do everything we can to reduce that risk and then reduce the safety risk of the folks that are working in our facilities. And so I've alluded to this a couple times throughout the presentation, just some steps for the positive outcome. Have that plan before the work starts, right? Make sure if you need to, bring a safety professional into the discussion. Plan for the worst. Make sure that you've got the safety and the rescue, there's the safety from local fire department, rescue crew, whatever the case may be. Make sure that you've had communications with them, you've talked to them. Make sure you know that conditions can change fast, right? You can, whether it's a quality or safety when you're dealing with a structure, make sure that folks are keeping the whole picture in mind, right? And then it never hurt anybody to pull them out of the situation and just stop for a minute. Stop and talk about what's happening, what's going on. Do I need to do something differently? Do I need to change plans? Right? Get folks out of harm's way, out of the situation, and redevelop that plan to manage the situation. And what I'd really like to leave you with is just some questions to ponder. Are you training and informing your team on the importance of grain quality? Right? Why am I doing this monitoring? Why do I need to notify these folks? Do they understand the importance of quality? And then that tie-in to safety, right? If you look back, for sure, a number of the injuries that I've dealt with and fatalities, 90 to 95% of them were because of a quality problem. Are you doing everything you can to monitor and manage your quality? Do you have a good plan? Does your team understand why, and how quickly a quality issue can turn into a safety issue? Right? You get the bridging, you get the chunks, you get the rat hole, whatever the case may be. And then when you have an issue, do you have policies and procedures in place to deal with them to make sure that you can keep the people and the facility safe?